a very small vlog about the developments of the radio coil tester, say the wobbulator, that has to work between 300 kilocycles and approximately 14 megacycles. You see here on this part of the circuit, this part is the sawtooth this is the oscillator unit that can oscillate with different coils, and here is a demo coil between 300 kilocycles and 14 megacycles. And the other part is the sawtooth generator, the sweep generator that sweeps the dot over the screen of the oscilloscope. And you can see it here. Say this is the dip, or say the exact resonance frequency, say where the coil performs at its best, and it is on 836 kilohertz. And that is logical. When we look to the radio theory and look at this coil, it's logical that it works in that frequency band. Anyway, that is, say, more or less practical knowledge. I'm still working on it. This is only, say, the first idea. There are quite a few flaws in this coil tester. For instance, that I cannot get here, say, the first part of the sawtooth wave. So I want, say, a sawtooth wave that moves, say, to the middle of the screen. Then we see the dip, or we see the resonance frequency, and then after that it's all what it is. So this was what is happening now. Here is that coil, and perhaps I can show a little bit from a certain distance what happens. I have to put out all the lights. What happens when I take the ferrite rod out of the coil or push it a little bit in. It's now at 835 kilohertz. Push it in, it means that we go to a lower frequency. So here, for instance here. And now we see, say, a kind of peak, and in the earlier it was a dip. So here we have the dip. So that's also, say, a thing that I have to search out, and here you can see that this dip gets enormously deep. Also a kind of thing that I have to find out more here. But it surely tells you that on, say, a certain frequency where that dip is at its maximum, the Q, the quality factor of the coil, is at its highest. And of course this is a dip, but I can also say this is a peak. So here, for instance, we have this coil on the workbench with the ferrite rod taken out quite a lot, and that means that the quality factor goes up. When you take the ferrite rod out, in general you get a more sharp peak resonance. So perhaps my idea that the quality factor goes up is not very okay, but anyway, the resonance, that is absolutely sure, the resonance of the coil gets very sharp. So the coil gets sharp, and you can see it here. Of course, you have to set your oscilloscope to the XI mode. So, and it is all at the moment quite unstable. You can see it all flickering, etc. But anyway, let me try to find. So here we have, in a certain way, this coil at its maximum performance. We even have here, say, such a high voltage that the scope cannot demonstrate the peak properly, and that is on for, well, the frequency is unsure. Anyway, thanks for watching all, say, practical radio theory. And well, let me try to find a peak where we can find a frequency that corresponds to it. And that is perhaps a little bit difficult. So, well, here for instance. So here we have a peak. So this is a kind of good demonstration. I think this is the peak, and we are on 886 kilohertz. 870 kilohertz. Anyway, this is the peak. So a lot to do to get this whole idea proper functioning. Well, indeed, a few there are some flaws that I have to say study and adapt and make that it works nice. Anyways, thanks for watching again.